NENOMATICA, where mathematics meets YouTube excellence. In this lesson, we will solve the problem exactly by following the algorithm on screen. Our goal is to understand Newton's binomial theorem, the powers in each term, how to compute each coefficient, and how to count the number of terms in both binomial and multinomial expansions. First, the core rule of Newton's binomial theorem. The expansion of open parenthesis, a plus b close parenthesis to the power n equals a to the n plus n over 1 factorial times a to the n minus 1 times b plus n times n minus 1 over 2 factorial times a to the n minus 2 times b squared, and so on, ending with b to the n. Step 1. Powers of a and b in each term. The power of a decreases from n down to 0, while the power of b increases from 0 up to n. Visually, this creates a neat diagonal flow of exponents across the expansion. Step 2. Coefficients. The coefficient of the kth term is the binomial coefficient, read as n choose k. It equals n factorial over k factorial times n minus k factorial. Another way to see it is as n times n minus 1 times n minus 2, and so on down to n minus k plus 1, all divided by k factorial. Step 3. The number of terms in a binomial expansion. The expansion of open parenthesis a plus or minus b close parenthesis to the power n always contains n plus 1 terms. For example, when n equals 7, there are 8 terms. Step 4. Multinomial terms counting. For k addends, the number of terms in open parenthesis a sub 1 plus a sub 2 up to a sub k close parenthesis to the power n equals the combination with repetition count, n plus k minus 1 choose k minus 1. As a bonus, here is how to compute a specific multinomial coefficient. The coefficient of x squared y to the first power z to the first power in open parenthesis x plus y plus z close parenthesis to the fourth equals 4 factorial divided by 2 factorial times 1 factorial, which is 12. In this example, we will find the number of distinct terms in the expansion of open parenthesis a plus b plus c close parenthesis to the power 98. We will use a general counting rule, sometimes called stars and bars for multinomials. Rule. The number of distinct terms that appear when you expand, open parenthesis, sum of k variables close parenthesis to the power n is given by the binomial coefficient, n plus k minus 1 choose k minus 1. Step 1. Identify n and k. Here the exponent n is 98, and there are 3 variables, a, b, and c, so k equals 3. Step 2. Apply the formula. Plugging in n equals 98 and k equals 3 gives binomial 100 choose 2. Step 3. Compute the value of binomial 100 choose 2. Start with the factorial form. 100 factorial over 2 factorial times 98 factorial. This simplifies to 100 times 99 divided by 2. Step 4. Now compute the arithmetic. Divide 2 into 100 to get 50. Then 50 times 99 equals 4,950. Why does this form? Example. Find the number of terms in the expansion of open bracket, open parenthesis, 2x plus 3y, close parenthesis squared, times open parenthesis, 2x minus 3y, close parenthesis squared, close bracket, all squared. First, simplify powers before expanding. We can bring the outer power inside as a power of a product. The expression becomes open bracket, open parenthesis, 2x plus 3y, close parenthesis, times open parenthesis, 2x minus 3y, close parenthesis, close bracket to the fourth power. Step 1. Multiply the binomials inside. Notice this is a classic difference of squares pattern. So, open parenthesis, 2x plus 3y, close parenthesis, times open parenthesis, 2x minus 3y, close parenthesis, equals open parenthesis 2x, close parenthesis squared, minus open parenthesis 3y, close parenthesis squared. That simplifies to 4x squared, minus 9y squared. Step 2. Rewrite the entire expression using that result. We get open parenthesis for x squared minus 9y squared close parenthesis to the fourth power. Here is a helpful rule. The number of terms in the expansion of open parenthesis a plus b close parenthesis to the n without like terms combining is n plus 1. In our case, a is 4x squared and b is negative 9y squared, and the powers of x and y are different, so the terms will all be distinct. Step 3. Compute the count. Here, n equals 4. So the number of terms is 4 plus 1, which equals 5. Therefore, the number of distinct terms in the expansion is 5. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.